So I saw this animation by Pierre Rapin. It's really amazing. Just look at how the plant grows. And it's done in Cinema 4D. It showcases a different kind of workflow that we don't unfortunately have in Blender. So I'm going to break down his tutorial and show how you can replicate it using Blender. Let me first show you what my results look like. Yeah, so I try to do the same animation here. The plant grows organically, grows like that, and it's all procedural. I can change a few things as I want. So here, let me show you how this looks in Eevee. You can see is that, and I can easily change a few things. By the way, the project files are going to be available on my Patreon page and my Gumroad page, so I can change the noise to get a completely different growth. Just look at that. Yeah, there are a lot of things you could do. You can also change the angle of the leaves. And that will also give you a totally different animation, which I think really looks cool. So let's see how we can set this up. So the first thing he did in Cinema 4D was make the flower animate like that, and let's do that as well. So this is our leaf, but to make it bend, I want it to be flat on the surface, and that way we get the best deformation. Okay, so this is our leaf, and to make it curve, all you have to do is create a curved curve. Have it somewhere like that, and now you just add a curve deformer to the object and select your curve. So if I move this, you can see I can easily bend the curve just like that. So I'm going to animate this for about 100 frames, just like that, so that we have something like that. If you go back to his tutorial, you can see after he does the animation, he goes on and clones this and then offsets the animation of each individual leaf. We don't really have a proper way to do that in Blender. You can't offset animations like this. So let me show you how I managed to do this. The only way you could do that is you could duplicate this and then offset the animation of this. But we're going to need a lot of leaves, and this is not a very efficient way to do it. So a more efficient workflow is to export this as an Alembic file. So just flatten hierarchy, selected objects, and the number of frames you want. So we can use about 150 frames, and yeah, I think that's it. You export. I'm going to have this in a collection. Call this original. You can disable that for now, and then I can import the Alembic we have. You can see it has the animation. Now let me also bring back the material, give it the material back. Now with this Alembic, you can duplicate it on the Y and offset the animation, the time right here. So I can offset this by 10 frames, but I think this starts to fold too late. So let me first go back to the original. I will just move this aside, go back to the original, and start my animation a bit early. So I'll start it at around, I'll add a keyframe here, just so that the animation starts a bit early. Now I have to re-export this. So file, export Alembic, and this will get an error because their data, it doesn't match anymore. So I just have to refresh that so that they use the new animation. Now, like I was saying, I can duplicate this on the Y, let's say 4 times, and start offsetting this, let's say by 10. Because these are all using the same data, you need to make sure that it's a different data it's a unique data for each. So this should not have any offset. This should have an offset of 20, an offset of 30, an offset of 40. So the animation would be something like that. And if you have these in a collection, I call these leaves. Now we can hide this. Go to geometry nodes. I'll set up a new geometry nodes. I'll create a spiral curve, a curve spiral like this. And let me make sure it's in the center. You can change the height. The start radius should be really small, and the end radius can also be really small, even smaller. Yeah, something like that. We can turn this to points, curve to points, and instance on points. And then we can bring in our leaves collection and separate children, reset, and yeah, use that as instances and pick instances. We need to make sure that this object here, which is leaf 5, yeah, make sure that you're adding it to a plane, not any object within, not a leaf object like this. So, okay, so now you can see our leaves. What you want to do is make sure that each point corresponds, each instance corresponds to a leaf you have here. That way we can have these leaves bend at the same time as the original leaves. So what we want to do is make sure that the number of leaves you have on this spiral is the same number of leaves we have in the collection to have the same animation as we have here. So let me join the spiral here so that we can see this correctly. To do that, we can get the domain size and just use these instances as to get the number of instances in this leaf collection and use that as the count. Let me bring the height down so that we can see what's going on much easier, and remove the rotations. Okay, so you can see this leaf we start with this leaf and then next and then the next and the next and then the next, like that. So they're creating that pattern we want. But the issue we're having is if we want more leaves, we would need to add more leaves to this collection. So you can see the more leaves I add, the more in this collection. If I duplicate these like 10 times, you can see I'm increasing the number of leaves in this, and then we'll get that pattern. But the problem is I would also have to come in here and offset these one by one. So I would do, so this is 40, this would be 50, would have an offset of 50, and I also need to make sure that it's its own unique user, and this is its own unique user. So this would be 90. That way we have the same offset here. You can see it becomes really, really tedious and hard to do. So I found the best way to do is to create a Python script that would do the same thing for me. If you don't know how to use Python, you can just copy the code from the project, but it's not really that hard. Okay, so this is what the script does. Again, you don't have to understand how it works. You can just copy the script I'm using from the project file. I'll also paste it in the description if you want to use it. You just have to understand the concept behind the script. Because Blender doesn't have a tool that does this, sometimes you have to do things yourself. So let me explain the tool here just a bit. So BPY is just telling Blender to use the Blender Python, that we're going to use Blender Python. And this line here gets this collection, so it accesses this collection, and the offset, we're just preparing our script to know that we want to offset this value here by a number 10, and what we are trying to do is go in on each object and add an offset of 10. This will be 10, 20, 30, 40, so that they can play sequentially. So we're going into this collection. We're checking if this collection exists and if this collection has objects. If it's empty, then the script will just stop there. If it has objects, then it will go in and go through each object one by one. And the first thing it will do is check if that object has modifiers. For example, I added a cube here, and it will check if that cube has modifiers, and right now it has this modifier. It's a bevel modifier, but that's not the modifier we want. We want a modifier called mesh sequence. It will just skip it and go to the next object, which would be this, and this one has that. And then the next thing it will do is making it a single user, just like that, and it will go in and make each of these objects a single user for this data. Then it can offset this by a number 10 by our offset here, multiply that offset by our index. So this would have an index of 0 and multiply it with the offset. So 10 times 0 would give us 0, and it will come here. This one would have an index of 1. So 10 times 1, it will give it a 1, it will give it a 10, and then 20, 30, like that, which will give us that sequence. So now with that, you just have to run the script, and you can see now everything should run sequentially as we expected. Yeah, as you can see, this has a 10, 20, 30, 40, 50, 60, like that. And I can even change the offset, maybe let's say 3, run the script. And now you can see that we have an offset of 3, 6, 9, and so on. So if I play back, it's much faster. So now you can see we have a nice pattern like that. I can also come in here, use a combine XY, and since we have a curve here, I can use a capture attribute and get its length using the spline parameter, so the factor, and use this as the Z rotation for the Z rotation, and just use a math node, multiply this to turn this, rotate it just like that. So you see, one thing I want is to start off while this is very small and then grow it. So what you can do is just go to edit mode of this original mesh, add a hook. So let me add an empty just like this, and just hook this entire mesh to that object. Control H, hook to selected, and that way at let's say we start off, we want here, just scale it to a value of 0, small, so that we have something like that. Then maybe offset this animation just like that. Now you can export this file, export Alembic, and we can again refresh this. So unfortunately, there is no way to refresh all of these at once. You can see what we have. Let me join the spiral here. So the reason why I'm using a hook instead of just scaling this down is that if you add any keyframes to this mesh here and export it as an Alembic file, so for example, if I duplicate this, let me remove this and just rotate it, give it a rotated animation and export it as an Alembic, call it 2. If I try to import it again, it will be locked in space, so you won't be able to move it anywhere. They add this constraint that locks it in place, so we don't want to do that. That's why I just use a hook. Now we want more leaves, so what you can do is just duplicate elements. I want to duplicate instances just like that, and do a rotate instances. You can see now we can rotate those, and I can use a combine X on the Z and just use the index. I can even map range, use a map range here. So if I can make make sure you don't have clamp on. So we want about 4 like that. So now you can see we have something like that. And you can do other things like animate this rotation. So I can randomize that using a random input, add it here, and so that there is some variation in this. So let me just like that. And another thing I could do is use time, scene time, just math, add it directly here. That way we have something like that. Creates a nice movement. And you can even just do, you can use a sine wave, turn this into a sine wave, as that way we can, let me multiply this, let's say by 2. So yeah, there's a ton of things you can do here. And you can also add some displacement here. So I can use a set position, some noise to this curve. I can use a noise texture, connect this to the offset, and use a vector math to subtract 0.5, a vector math, and use the scale option to either make this super strong or, and now you can turn this curve into a mesh, curve to mesh here, and give it a curve circle. I'll give it a material. Use a set radius. I use a trim curve and use a set radius here, and just use a spline parameter. I think it needs to be inverted, so I'll use a float curve to just invert. And you can use time, scene time at the number of frames to animate this stream, but you need to map range. So this can be, we want this animation to end at, so it ends at around 126, so I can do the maximum to be 126. It's a bit faster, yeah, but I think it's good. And let me just reduce this. Oh, I think this set radius has to come after the trim, not before. So yeah, and so that's how we ended up with this. I think this one is even more elegant because I spent a little bit more time on this. Yes, thank you for watching. I'll see you in the next video. Project files are going to be in the description on my Patreon and my Gumroad page.